Hi again, everyone. We are going to start Chapter 6, and we'll do Chapter 6 in two different videos for rational expressions and rational equations. Rational expressions are just fractions that usually have a variable mixed in with them. And so what we'll be doing in this section is taking the idea that we were doing last video with factoring and applying that to what if you took two fractions and you multiplied them or divided them or added them or subtracted them, and see how they can be combined together using the factoring. So first of all, let's talk about domain real quick. The domain of a rational function will be all the numbers except the ones that make the denominator equal to 0. And we'll have to do this once we get into actually solving some equations that have rational expressions in them. So when you're looking at finding the domain, it does not matter what's on top. So this x squared plus 15 has no bearing in the problem when you're doing domain. You're looking at just whatever's on the bottom. So I'm going to take what's on the bottom, this x squared minus 6x minus 7. And I set that equal to 0 because I want to find out what values I do not want to include on my domain. And so this is just like what we were doing last video with factoring. You look at this sign right here, that's a minus sign. So I'll have to have two sets of parentheses, one with a plus, one with a minus. And then I look at these two numbers, the 6 and the 7, and I need two numbers that multiply to 7 that either add or subtract to give you 6. And so I would use 7 and 1. Because the 6 is negative, the bigger one gets the negative, so that's the 7 and the 1. And I'd get x's for the x squared. And you can FOIL it to make sure that you have that right. Then you set each one equal to 0, much like what we were doing in the last video. Either x plus 1 equals 0 or x minus 7 equals 0. Subtract the 1 from both sides and add the 7 to both sides. And I'll get that either x is negative 1 or x is positive 7. So those are the values you do not include in your domain. And there's several different ways to write this. You can write it in interval notation, or we could write it in set notation, or we could write it just in a list of numbers that whatever numbers you don't want to include. So I could say things like this. My domain would be all the values for x other than x cannot equal negative 1 and 7. Usually if they write it this way on the homework, all you're going to be doing is filling in a blank where the negative 1 and the 7 would go. That's your set notation. You could also do an interval notation. We don't really talk about interval notation here, but you will in the next course. It's a little bit more complicated, so I won't do that one. So, to simplify fractions, what we want to do is factor everything we possibly can. We would factor the top, we would factor the bottom, and hopefully something would cancel along the way. And so on the top, we have t squared minus 4. On the bottom, we have 2t minus 4. You'll have to look at these things and decide what type of factoring that we were talking about in the last chapter matches with this particular problem. So for instance here, that top part, you'll have to notice that that is the difference of squares. This is your a squared minus b squared. And so I could write this as t squared minus 2 squared. And if you remember what we did with that, that became a plus b and a minus b. So we would write this as t plus 2 and t minus 2. You write one with a positive, one with a negative, and drop the squares off. So that's the top one. The bottom one is only a greatest common factor. There's a 2 in common. You can factor the 2 out in front, and you would have a t and a minus 2 left over. And so what will happen is there's a t minus 2 on top and a t minus 2 on the bottom that can then cancel each other off. And so my answer is just t plus 2 all over 2. Now, do not do something like cancel the 2's off and say the answer is just t. That's not true. You cannot cancel things that are added or subtracted. You can only cancel things that are either multiplied or divided. So let's do a couple more of those type problems. Here we have one that's a little bit more complicated, 2y squared plus 9y plus 4, and 2y squared plus 7y plus 3. Now when we did these back in the last chapter, I noticed that if you have a number in front of the squared term, you can rewrite it. You can move this 2 and multiply it by this 4, or this 2 and multiply it by that 3. And I'm going to rewrite this as y squared plus 9y plus 8. And on the bottom, I'll have y squared plus 7y plus 6. Notice here, they're both positives for that second sign. That means when I do my two parentheses on the top and on the bottom, they both have to be positives. Well, that positive tells you they're the same sign, but the fact that there are positives that are in front of the 7 and the 9 tell you that they have to be the same sign, that are positive. The y squared will just become y and y on every one of them. And then the top one, you need two numbers that multiply to 8 that add to give you 9. So in this case, I would use 8 and 1. And the bottom one, I need two numbers that multiply to 6 that add to give me 7. I would use 7 and 1. Now, at this point, because I multiplied by 2 at the very beginning, I have to divide everything in the problem on the number side. I have to divide that by 2. And so this will actually factor into y plus 4, oops, sorry, I forgot the parenthesis there, y plus 1/2, y plus 7/2, and y plus 1/2. Notice the y plus 1/2 cancel. Sound effects are important too. And if we did factor it and we ended up with a fraction, we move that fraction back in front of the variable. And so I would say that my answer is y plus 4 over 2y plus 7. So it's a little bit more work than what we were doing in the last chapter because you possibly have to do multiple factoring all the way through the problem. So let's do number 4 down here. This is a difference of squares again, the x squared and the 25 that is on top. I could rewrite that top part as x squared and 5 squared. And so that top part would be turned into x plus 5 and x minus 5. Now the bottom has absolutely nothing in common. You can't really do anything with it, except that if I want it to cancel, I can't have 5 minus x. I'd rather have x minus 5. So anytime you want to reverse a polynomial like this and make it go x minus 5 instead of 5 minus x, you take out a negative 1. So if you divided everything by negative 1, or pulled a negative 1 out, you'd actually end up with negative 5 plus x. Or that's the same thing as x minus 5. So if you ever want to reverse it, factor out a negative. That way the x minus 5's cancel, and you're left with your answer of negative 1 times x plus 5. Or you could distribute the negative 1 across and make it at negative 5 and negative x, and make it negative x minus 5. Now we're going to take this a step further and say, what if you have multiple fractions that are either added or multiplied or divided? If you multiply or divide fractions that are rational expressions with variables, what we have to do is we factor everything in the problem and then see what cancels. And if you're dividing fractions, you just flip it to make it multiply. And this could be any type of factoring along the way. So the one on the left, the x squared minus 10x plus 24, and the x squared minus x minus 30, both of those are trinomials. And so we'll do the reverse foiling kind of idea. The ones on the right are both difference of squareds. X squared minus 25 is the same thing as x squared minus 5 squared. And x squared minus 16 is the same thing as x squared minus 4 squared. And so we'll factor these fractions a couple different ways. And so the top one will turn into, notice we have a positive, that tells you the signs are the same. This negative tells you they're both minus signs. And the x squared will become x and x. And you need two numbers that multiply to 24 that add or subtract to give me 10. I'm going to use 6 and 4. On the bottom, this sign tells you that the signs are different. One's got to be a positive, one's got to be a negative. The x squared again is still x times x. You need two numbers that multiply to 30 that either add or subtract to give you 1. I will do 6 times 5, and the 6 is negative plus the x is negative. The bigger number gets the negative. On the top right, like we said, this is x squared minus 5 squared. And so I'll get x plus 5 and x minus 5. And on the bottom, this is x squared minus 4 squared. So I'll end up with x plus 4 and x minus 4. The factoring is the hardest part for most people because once you get to this step now, you can cancel vertically and you can cancel diagonally. So vertically would be like this x minus 6 and this x minus 6 on the bottom. They cancel. Diagonally would be like this x plus 5 with this x plus 5 on the other fraction. Or this x minus 4 with the x minus 4 on the other fraction. But you cannot cancel horizontally. If you're on the same level, they will not cancel. And what you have left over is an x minus 5 and an x plus 4. And that's what you want to do. You try to simplify it as much as possible by factoring everything out and then canceling what you can. Okay, so this one's kind of the same idea. You want to try to simplify it as much as possible. Here, this is probably kind of the worst case scenario though. We have numbers in front of the u's all the way across, so we'll have to adjust our problems for that. And they're all trinomials. So this is probably going to be the one that's the most amount of work as far as multiplying or dividing two fractions together. So just like on the other ones, I'm going to multiply these numbers that are in front by these numbers that are in the back. So I don't know if you can see this arrow on this top part, but I am doing the 12 times the 1 and the 2 times the 6. So I'm going to rewrite this as u squared minus 13u plus 12. Then I'm going to write the bottom one as u squared plus 3u minus 4. Then I'm going to do u squared minus 8u plus 12. And then u squared plus 11u minus 12. So they're all going to end up with things that have parentheses on them. So one set of parentheses, another 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 set of parentheses, because they're all trinomials. So we're basically reverse foiling here. So the first one, the u squared minus 13u plus 12, this is a positive sign. The sign in front tells me what they should be, so they're both minus signs here. And you're looking for the u squared will be u and u. And you're looking for two numbers that multiply to 12 that add to 13, which would be 12 and 1. On the bottom one, the 4 tells you they're, with the negative in front of the 4, they tell you they are opposites, so I have a plus and a minus. The u and u becomes the u squared. Two numbers that multiply to 4 that add or subtract to give you 3 would be 4 and 1. Since the 3 is positive, the bigger number gets the positive, the 4 and the 1. On the third one, the top right, we have a minus sign, very much like the first one. Since it's a minus sign in front of the negative 8 and a positive in front of the 12, the positive in front of the 12 tells you they're the same sign. The minus sign tells you they're both negative, so we'll put two negative signs in here. The u squared becomes u and u. I need two numbers that multiply to 12 that add or subtract to give me 8. So I'm going to do 6 and 2. 6 times 2 is 12. 6 plus 2 is 8. And on the last ones, we have a minus sign in front of the negative in front of the 12. So that tells me I need a positive and then a negative. The u squared will become u and u. And I need two numbers that multiply to 12 that add or subtract to give you 11. So that would be 12 and 1. Ooh, excuse me. And then the 12 would go with the positive sign because the 11 is positive. The bigger number gets the positive. And a 1. Now, because we multiplied by all these different numbers, I now have to go back and divide by all these different numbers before I start canceling things. So on the first one, I multiplied by 2. So I have to divide the first ones by 2. The one on the bottom left, I also multiplied by 2, so I'll divide by 2 there as well. The top right one, I multiplied by 12, so I will divide by 12 on everything. And the bottom right, I multiplied by 6, so I will divide everything by 6. This will leave me u minus 6, u minus a half. That one didn't simplify very well. U plus 2, u minus a half. The top right gives me a u minus a half, so 6 divided by 2. Sorry, 6 divided by 12. 2 divided by 12 will go to 1/6. A u plus 2. And a u minus 1/6. Then what we do is we go through and cancel whatever we possibly can anywhere in the problem. So in this case, vertically, I can cancel the u minus a half on each one, and I can cancel the u minus a sixth on each one. I cannot cancel the u plus 2. Notice they're on the same level, on the bottom right and on the bottom left. So if they're on the same level, they can't cancel, and nothing actually else cancels in the problem. So at this point, you're kind of stuck. The only thing I would do is go ahead and move this 1/2, move this 2 back in front of the u, and make this u minus 6, 2u minus 1, a u plus 2, and a u plus 2. Or you could do u plus 2 all squared if you wanted to. Either one would be okay. Now when we add and subtract fractions though, what you want to do is get a common denominator. So we want the least common multiple. That's what LCM stands for, the least common multiple of the numbers. And we use the highest power. So this is kind of backwards of what you do with factoring. Factoring uses the lowest power to pull out front. Here we want the highest power on each letter for the common denominator. So between the 9 and the 6 that are on the bottom, between the 9 and the 6 that are on the bottom, what you want to do is find a number that they both go into. Again, you could do it by multiplying together. We've talked about that in the past already. 9 times 6 is 54. So 54 would work. That's not the least common one, but that one would work. So we want to try to find the one that's the least possible. And the least possible one would be 9 goes into 18, and 6 goes into 18. And so I'm going to use 18. You can also find it like this. 9 is 3 times 3, and 6 is 3 times 2. You can kind of split them up and then figure out the least common multiple by noticing I need to have at least 2 3s, and I have to have at least 1 2. If you did 3 times 3, that's 9 times 2. These two together give you 18. That's one way to do it. Or you could just think about what number does 9 and 6 both go into, whichever one you want to do. So I'm going to rewrite these fractions to have a 18 on the bottom. Now to get to 18, I had to multiply 9 times 2. So on the top, I also have to multiply by 2. And to go 6 to 18, I would have had to multiply it by 3. So I have to adjust the top as well as we go along. Then I need the highest power on the x's. That would be x cubed. 3 is bigger than 2. The 9 had the x cubed. The 6 only had an x squared. So I increased the x's by 1. So I have to put 1 additional x on top as well. And the y's all match already. Y to the first power. So we're actually subtracting 4 minus 3x on top, and we put it all over one common denominator. And that would be my answer. I did the 2 times the 2 to give you the 4 on the top. The 1 times 3 times x gives you the 3x. And I take the 1 denominator on the bottom, and that puts your two fractions together. So let's do another one just like that. Here, between the 8 and the 2, I need a number that both 8 goes into and 2 goes into. And so in this case, the answer would be 8. So I need an 8 on the bottom. Oops, that was supposed to be a straight line. It's kind of straight. See if I can make it a little bit better. So I'm going to need an 8 on the bottom. And 8 on the bottom. Now the 7 already had an 8 over it, but the 3 had a 2 over it. And to go from 2 to 8, I multiplied by 4. So I will have to multiply by a 4 on top of the right one. And again, you take the highest power. So between the x and the x squared, I would do x squared on both. Now, again, on the left, the 8x squared was already 8x squared. But the one on the right, the lower right one, we have a 2x. I made it an x squared. I had to add an additional x to it. So that's what I'll put on top. And the y's, the highest power, is y squared. On the one on the left, it was 8x squared y. I had to stick an additional y on there. So that additional y I stuck on there, I'll have to put on top. And then the 2xy squared already had y squared, so we don't have to do anything to the second fraction. So what we'll have is 7y plus 12x all divided by 8x squared y squared. And that's my answer. Now, some students get a little bit more confused when you do things instead of like what we just did on those two. If we do ones that have things like number 9, x plus 6 and x minus 5. You have to treat the things that are added and subtracted together as one term. Just like on number 8, it was x squared. That is just an x that's squared. On the number 9, it's x minus 6, or sorry, x plus 6. That x plus 6 is just like that 1x. It is just 1x plus 6, and it's just 1x minus 5. So my denominators here, to make this work, the one on the left is 1 x plus 6. I need the highest power of the x plus 6's that you have. So my highest power on the x plus 6's is x plus 6. So I need an x plus 6 on the bottom of each one. And my highest power on the x minus 5's is x minus 5. So I need an x minus 5 on each one. Now the 2x on the top had the x plus 6, but it did not have the x minus 5. And the 7x had the x minus 5, but it did not have the x plus 6. So we're adding that additional term on the top of each one. Don't at this stage, don't do this at this step. Some people have the idea of saying, oh look, an x minus 5 is in common, I'll cancel them. Don't do that, because then you're right back where you started. We don't want to go that direction. So what we want to do is FOIL or distribute the top out. So across the top I'll have 2x squared, and then 2 times 5 is 10x, and then I'll have 7x times x is 7x squared, and 7 times 6 is 42x. All divided by the common denominator, just like we did on number 8. The common denominator is the x plus 6 and the x minus 5. Now, you never multiply the bottom out. Don't ever multiply the bottom out. But we do want to multiply the top out just to see if it'll simplify any. And so on top, I'll get a 9x squared and a positive 32x. And then we'll have x plus 6 and x minus 5. And that would be my answer. Now, it is possible at this step that you could have something in common that you could factor out and cancel it. If you do, go ahead and do that. Here we don't. There's not a number that 9 doesn't go into 32 or 3 doesn't go into both of them. So you can't factor out a number. You could factor out an x, but it won't simplify. So I'll just leave it like that. Okay, let's do it another one of those type problems, except now we're going to do it with 3 fractions. So notice the one on the far right, 15 over w squared plus 3w. To get my common denominator, I have to have it factored. And so I'm going to factor that fraction there. So I'm going to rewrite this as 5 over w plus 3, 2 over 3w, and 15 over, there's a w in common. So if I factor the w out, I'll have w plus 3 left over. So my common denominator would be the biggest amount of terms that you have of whatever you have. Like for instance, I have 1 3 on the bottom in front of the 3w. I have a w to the first power, and I also have a w plus 3 to the first power. So my fractions will have to have a common denominator that will include a 3, a w, and a w plus 3 on each one. A 3, a w, and a w plus 3. A 3, a w, and a w plus 3. Now that first fraction had a 5 on top. But it also had a w plus 3 on the bottom. I had to stick the 3w on the bottom to make it be the common denominator. So I have to stick that same 3w on top. On the second one, I had a 2. It was over 3w, but I had to add in a w plus 3. And on the last one, I had a 15 on the bottom. I had the w and the w plus 3. What I was missing there was just the 3 in front of the 3w. Multiply that stuff across the top, and I'll get 15w. I'll get 2w plus 6, and 15 times 3 is 45. All divided by that one denominator of 3w and w plus 3. Oops. Now in this case, notice the 15 and the 2 make 17w. 45 and 6 is 51 over 3w times w plus 3. I think this one will actually simplify, because 17 and 51 are both divisible by 17. So if I was to pull the 17 out in front, I would have w plus 3 left over. Oops, not negative 3, just 3. And so if it does simplify, we do want to go ahead and simplify it. The w plus 3's cancel. And so this whole thing is 17 over 3w. That simplified a lot more than I thought it would. Okay, let's do a subtraction one. On the subtraction, you have to be kind of careful with that minus sign. I do want to factor all the stuff on the bottom that's possible. So here, we'll end up with 2 trinomials that will factor into 2 binomials. So we'll kind of do the reverse foiling thing again. I have a positive on this 4. So that positive tells me to look at this sign and see what it is. So they're both minus signs. And I need 2 numbers that multiply to 4 that add to 5, which would be 4 and 1. On the other one, same idea. This positive tells me they're the same sign. I look to the other sign, see it's a minus sign, so they have to both be minus signs. And I need 2 numbers that multiply to 1 that add to 2. I'm going to use 1 and 1. So what I have here is 3 over x minus 4 and x minus 1. And I really have 2 over x minus 1 squared. And so my common denominator is the highest number of terms that I have. So I have an x minus 4, but I have my higher power would be x minus 1 squared. So when I do my common denominator, I'll have an x minus 4 and an x minus 1 squared. So on the top, I had a 3. The 3 was over the x minus 4 and the x minus 1, but not x minus 1 squared. I had to stick an additional x minus 1 on top. And on the other one, I had a 2. It had the x minus 1 squared, but I had to put an x minus 4 on top. And this is where you have to be really careful. The minus sign that's between them is on the 2, which gets distributed onto each one as we go across. So this will become 3x minus 3 minus 2x and plus 8. Where people mess up is the plus 8. Some people put minus 8 there because they don't take the negative all the way across. So be careful with that. And we'll have x minus 4 and x minus 1 squared. Combine your terms together, and we're going to be left with an x on top and a plus 5, which will not simplify with the x minus 4 or the x minus 1 squared. And that's my answer. So be really careful on the minus ones. Okay, the last thing in this video will be complex fractions. A complex fraction is where we have a fraction inside of a fraction. And what we want to do is get rid of the little baby fractions inside of the big fraction. So that's what I'm going to do here. I have 1 over x plus 9, all divided by 1 over x minus 6. What you want to do is you take the common denominator of the little baby fractions, and that's what you multiply on everything. So in the first case, there's only an x on the bottom, on either one. So the common denominator would have to just be this x. So I'm going to multiply everything in this problem, even the 9 and the 6 that aren't fractions, with an x. So multiply x everywhere, 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 everywhere. And what will happen is the little baby fractions cancel. That's what you want to happen. This x cancels that x, this x cancels that x. And what you're left with is a 1 on top and a 9x. And on bottom, you're left with 1 and a minus 6x. And that's it. That's all you do. That gets rid of the baby fraction, which is the goal of these problems. Now, number 12 is a fairly easy one to do, so don't get your hopes up quite yet. The one on the bottom is a little bit more complicated. So you need a common denominator for the 8, the 16, and the 2. So you need to come up with a number that 2, 8, and 16 all go into. Now again, you could multiply them together and get 256, but that's way, way, way more than you need. The 16 works for all of them. 16 goes into 16, 8 goes into 16, and 2 goes into 16. You also have a y on the bottom right, 7 over 2y. That y has to be part of your denominator as well. So I'm going to multiply everything in the problem by 16y. And you'll know that you got the common denominator correct if you end up with all the little baby fractions canceling. So I'm going to multiply everything by 16y. Including the y on the top, it's not a fraction. And then I get 35 over 16. That's multiplied by 16y. And then I have the 7 over 2y. That is also multiplied by 16y. And then we go through and hopefully start canceling things. Like, for instance, this 16 cancels that 16. This y cancels this y. This 2 cancels the 16 and makes it an 8. The 8 cancels the 16 and makes it a 2. So what we're left with is 16y squared. Now again, you have to be careful on the top part. Since it's a minus sign, this 2y will get distributed on the 8 and the 3y, but it's really a negative 2y because there's a minus sign in front. So negative 2y times negative 2y times the 3y will give me a minus 6y squared. And the two negatives make a positive on the 8 times 2 will give me a positive 16y. On the bottom, you're left with 35y. And on the other one, 8 times 7 is 56. And this will probably simplify. Notice the 16 minus the 6 gives me 10y squared plus 16y. On the bottom, I just get 35y minus 56. So if I were to simplify this, there's a y in common on top. There's also a 2 in common. So if I factor out the 2y in common, I'm left with 5y plus 8. On the bottom, there's a 7 in common. If I pull out the 7 in common, I'm left with 5y. Oh, I made a boo-boo, didn't I? It's 35 over 16 plus 7 over 2y. So these are plus signs on the bottom. I was thinking it should cancel. So sorry about that. There's a plus sign supposed to be on the bottom all the way through. In case you were questioning why did he carry the plus sign, that's the reason. I just forgot. And notice the 5y plus 8 and the 5y plus 8 cancel. So this whole thing is nothing more than 2y divided by 7. Now, I've done this problem in the past, and some people say, hey, is it a coincidence that if you look at the original problem, there's a 7 over 2y right here? Is it always that 2y over 7? Just flip it over and that's your answer. And I hate to say yes or no, because if I said yes, it's always the same thing, then you don't do the work to come up with the right answer. But if I say no and it always works, then you start questioning whether I'm stupid or not. So I'll let you decide if it always works or not. That's the end of this video. And so we'll do some more in chapter 6 in the next video when we actually solve equations with it.